Let's say you would like to train a machine to recognize handwritten digits. Now you could come up with set of rules which define how these digits look like, but given the huge variation between people's handwriting, you will find you will need so many rules with even more exceptions, and this is going to make the life of your machine difficult in terms of being able to generalize from those rules. Now a better approach would be to provide data to your machine and let it learn from the data the patterns which define a particular digit. So how might we go about doing that? Well, for each of the digit, what you can do is, well, you can digitize it. You can take a, let's say, a picture and represent it by an n by m array of pixels. Let's say we have 20 by 20 pixels. Each pixel, let's say, is 8 bits in size, and so it records a number between 0 to 255, indicating the gray level intensity that is measured at particular pixel. So in this way, what we end up having here is a vector of 400 features to represent a particular digit. When you are extracting the features, it's important to minimize the variation within a particular class. So if you look at the way people would write 0, there are so many variations, yeah, and so you would find that there is a bit of pre-processing that is involved, which would look at, for instance, scaling and translating the images such that it fits nicely within this 20 by 20 box in the center. So this is part of the feature extraction process where you're trying to minimize the variation within the class, and this will help your machine learn to differentiate the digits better. So after feature extraction, what we end up having would be something would be called a training set, which will consist of your 400 features of real valued pixel intensities, and for each set of these features you have a class label that identifies the digit, right? So each line in this table that you see is called a training instance, and this is the class label. This in itself is called the training data. The idea here is for the machine to be able to learn the pattern from the training data such that it's able to recognize the digits. Given an unknown vector, it should be able to recognize the digit. So after it has been trained, we test how good our machine is by subjecting it to a test data set which would have been obtained in the same way the training data set was obtained, using the same feature extraction techniques. So you will have the same 400 features, and the class label is not going to be shown to the machine. So you give it some unseen or never before seen set of features and get the machine to classify it, and that will tell you the accuracy, how well it is able to generalize. So this is very important part in machine learning, being able to generalize a concept. You can do well in a training data set, but how well is the machine able to perform on set of data which is new to it? This is kind of similar to how examination works. In the class, we teach you a particular concept and provide you with examples, but when you come for your final exam, the exam paper tests the same concepts but using totally different questions. So if you are able to apply the concepts you have learned to generalize, that's the higher form of learning. The lowest form of learning would be to just simply remember things. If you just remember your training data set and are able to score well, then you will only be able to perform better if you get to see an instance that you have learned before. If you are subjected to a test environment where you are seeing questions for the first time, you will not be able to perform well. So it's important for machine learning algorithms to be able to generalize from a given training data. So in summary, what is machine learning all about? Well, it's about learning from data. And data in the real world has noise in it. Take, for instance, the simple example of digitizing the digits. When you take an image, the camera is going to introduce noise because of the sensor and electronics. You have variations in the features which are recorded. So real world data is noisy, and the job of a machine learning algorithm is to be able to learn the underlying model from noisy data such that it is able to generalize on set of data that it has not seen before.